Okay, in this video, we're going to talk about gas law in stoichiometry. So let's review a little bit about stoichiometry calculation. If you have a balanced chemical equation, a balanced reaction, basically, you can do stoichiometry calculations utilizing the coefficients. Now, A is a known compound, and B is another compound that you're trying to find out. So the mole ratio here, mole to mole conversion from A to B, is going to be the coefficient ratio. Most of the work will be focused on actually converting any amount of compound A into mole of compound A, such as mass of how many grams A. You can divide that by the molecular weight to find out the mole of A, and then you go to mole ratio. And from mole of B, you can find the mass of B using the molecular weight of compound B. We'll also talk about the molarity. Okay, you can use the volume molarity to find the mole of compound A. When it comes to gas molecules, we used to be able to do gas of chemicals at STP conditions. We usually use the number of 22.44. But now, since we already know how to do gas law calculation, so we don't use that number anymore. Because if you think about this, we have a much more powerful tool here, which is PV equals to nRT. Now here, N is the mole of the compound, either A or B, okay? And then if you can calculate mole, and if you have any one or two of the other things, R is a constant, then you can calculate the volume from there, such as V equals to nRT over P. You can calculate mole. If you are given T and P, then you can calculate volume. So we don't use that 22.414 anymore, okay? So we can combine the gas law calculations, adopt this gas law calculations into the stoichiometry. And the same thing, once you have the mole of B, you can calculate, use the PV equals to nRT to calculate whatever you need to calculate. It doesn't have to be volume, it could be even pressure or possibly temperature. Okay, we're going to use maybe a couple of examples to show you how to do this kind of work. Okay, so basically, here are two examples. As usual, we're going to work out one at a time, and then you can, finish working out the first one, you can think about doing the second one. And of course, I'll work with you on both questions together. Alright, so here's a given chemical equation here, apparently. Okay, it's balanced. The question says passenger airbags typically contain 200 grams solid Na-3. Keep in mind, okay, we're still talking about ideal gases, so we don't really care about what kind of gas. But since we're dealing with a stoichiometric problem, so you might want to keep in mind here might be given something else like grams. Okay, so here's where you need to focus on whether this compound is a solid or is a gas. Okay, solid obviously don't apply to gas law. Okay, only gases apply to gas law. So when you're given a mass number, okay, of solid Na-3, so you know this is not about the gas law, but you still want to write down that number. Okay. If you're given a gram of one compound, okay, apparently this is going to be your A. The compound will undergo rapid decomposition. Decomposition reaction usually means one molecule will be decomposed into smaller pieces, okay, like in this one. By an electrical charge to produce nitrogen gas. Okay, so this is sounds like the gas molecule has been mentioned here. calculate, and I always ask students to focus on this kind of wording. Okay, calculate, find out what is. This is usually directly pointing you to the compound B. Calculate the pressure. Okay, so you're trying to find the pressure inside a typical 60 liters airbag. So you're given the volume. If the temperature of the gas is okay, it's 95 Celsius degrees. The temperature is 95 Celsius degrees. You can almost immediately convert this into Kelvin, okay, before you even forget it during the full deployment of the bag. So you're asking for the pressure, given volume and temperature of the gas. Now in this case, you have to be very, very careful. Okay, gas here referring to nitrogen gas only, not this compound. Okay. So you're talking about nitrogen gas here for volume, temperature, pressure, and even possibly N. Okay, which is not given to you directly. So if I can find the mole of B, and then I can plug into pressure equals to nRT over V. So I can calculate the pressure. I have R is a constant. Okay, R is a universal constant. Temperature and volume were given to you, and mole is something we can find out, and the pressure is what we're trying to find out at the end. So how do I find the mole of compound B if I'm given a mass of compound A? So this turns into a typical stoichiometry problem. Okay, so the first part of this problem should be, how do we convert 200 grams NaN3 into mole of nitrogen gas? And this is I can't overaddress this. Okay, you have to know what is the gas molecule you're looking for. Okay, not this guy, it's nitrogen gas. So mass of A, trying to find the mole of B. Okay, so the first thing is going to be, according to this, we're trying to find mole of B, and then we have mass of A, so we need to do mass to mole conversion first. So the mass to mole conversion is going to be gram of NaN3 down here, mole of NaN3 up here. So this number divided by molecular weight. 1 mole weighs, the molecular weight of this guy, you can calculate it by adding up sodium and 3 nitrogens. It's going to be 65.03 grams. Okay, so this is the molar mass of the sodium nitrite. Now times, this will give you mole of A. Okay, mole of A will be converting to mole of B, which is nitrogen gas, and the mole of A should be cancelled by staying down here, and the mole ratio here is going to be directly relying on the numbers here. Okay, make sure you follow the right numbers. So 3 in the front of nitrogen, 2 in front of NaN3. So this will give you, so this is basically give you the N. Okay, little n. Mole of nitrogen gas is 4.615 mole nitrogen gas. Alright, so that's the first half. First half is to find out the n. The second half is going to be, this is the stoichiometry part. Okay, second part is going to be gas law part, which is going to be PV equals to nRT, and you're looking for calculate the pressure. So we're looking for pressure equals to nRT over V, and we have everything. Okay, mole is 4.615. R is a given constant. Temperature is 368, and the volume is 60 liters. And so you do have to count sig figs of all the numbers. Okay, 200, start from 200, that has 3, so this number should have 3. R is a constant, you don't really count sig figs. 368 has 3, 60 has 3, so at the end you only have 3 sig figs. pressure is going to be 2.32. The unit here, okay, the unit here is going to be ATM, since you're using mole for mole, Kelvin for temperature, and the liters for volume, then you're guaranteed to have ATM unit pressure at the end. So this is the answer.